Oh, it is on. Excellent. All right. It's a particular pleasure to be able to introduce this seminar. It has been a little time coming. I had to ask Ellycia exactly how long it has been. In fact, this has been an 8-year process, but a highly productive one, including 2 children as well as the thesis. So, you know, this is a person who's been working very, very hard on a number of different fronts. It's also a particular pleasure to introduce Ellie's seminar, because I think this is one of the most important seminars that we are going to be hearing in quite some time. There's a fascinating puzzle or problem that emerges in the environmental policy space as to why some issues become prominent and others don't. So I suppose the pin-up issue in environmental policy has been ozone depletion and ozone depleting substances, which went from being recognised by scientists in the early 1980s, and within about 5 years moved towards an international treaty, which then worked very effectively to reduce the problem quite significantly. By contrast, there are a number of other problems which have taken a long time to first emerge and then to find some form of framing, both in the public mind and also in terms of political institutions and governance. Climate change is clearly one of them. Ocean acidification is another. And in fact, ocean acidification has had far less prominence than climate change, though it is obviously very closely related, and as Ellie, I'm sure, is going to explain, is diabolical in terms of its consequences. That problem of framing, I think, is a particularly interesting one. Scientific framing in the first hand, framing in the public imagination, the public and social imaginary, and then, of course, the elevation of the problem to one which is recognised by politicians, by political institutions, and then formally inscribed in both formal and informal forms of governance. In the case of ocean acidification, it's a persistent puzzle as to why this hasn't happened to the degree that it should have. And so Ellie's thesis is particularly important because it's grappled with this exceptionally important problem directly. That's all I want to say. I want to hand over to Ellie. There will be questions afterwards.
Thank you. Thanks, Peter. And as Peter said, I just want to also acknowledge Rachel Hughes and Ove Goldberg, my other 2 supervisors, and also John Barnett, who's the chair of my committee. And so, as Peter said, I have been grappling for the last 8 years with this issue of governing ocean acidification. And I've been looking particularly at the role that multilateral environmental agreements can play. And in terms of sort of governing ocean acidification and dealing with this issue, as yet there are no multilateral environmental agreements that actually list ocean acidification in their treaty texts. There's no specific legal instrument that has been created to address ocean acidification. So at the moment it sort of sits in this no man's land. There is no multilateral environmental agreement that has been designed to address this issue, in part because this issue is a relatively new one. It's only been recognised by the scientific community in the late 1990s, and it was only really sort of the mid-2000s that the scientific community really started grappling with it, and then the policy community in turn started to pick it up. So in that sense, it's a really, really new issue as well. And so when we think about sort of the swathe of multilateral environmental agreements that we have, they all predate ocean acidification. So how do you tackle an issue that's new on the scene? So a lot of people have suggested, well, we should tackle it by creating a new multilateral environmental agreement, which on the face of it sounds like a great idea. Why don't we create a new agreement that can specifically address ocean acidification? One of the problems with that is that ocean acidification is highly interconnected with a whole lot of other environmental problems. As Peter mentioned, climate change is one of them. So ocean acidification is caused by CO2, which is ultimately one of the main drivers of climate change as well. So if you're going to tackle ocean acidification, if you're going to mitigate ocean acidification, you need to address CO2, which is already being addressed by the UNFCCC. So would a new ocean acidification agreement take on the issue of CO2? Would it somehow overlap with the UNFCCC? How would you actually address, how would you design this new agreement? And so a lot of people have actually said, whilst we need an ocean acidification agreement, there's going to be huge areas of overlap between all these other agreements that already exist. And so you have this highly congested international space where ocean acidification seems to overlap with a whole lot of existing MEAs and yet fall between the gaps at the same time. And so that's how I came to this problem. How does ocean acidification sit within this highly congested landscape? And so before, how do I get it to move? Yeah, there. So before I start, I just want to thank a few people. Firstly, my supervisors and John for sticking with me for the last 8 years. I also want to thank everyone here at the college. I couldn't have done this incredibly long journey without you guys. All of you have been wonderful supports for me. I want to thank Alex for flying in from Germany for this. And last but not least, my partner, Jonathan, who has been my ultimate rock during this process. He has been the shoulder that I've cried on many, many times, but he's also been the person who's really pushed me and helped me to get through this. And so as you can see, it has been a very, very long drawn out process. Thankfully, with a few publications and opportunities to speak at conferences along the way. The last 3 publications I've had are all chapters in my thesis as well. So I am doing a PhD with publication. So my last publication was just accepted last night at 9:30 by Climate Policy. So I'm very happy to have that one go through. And so whilst this looks like a very happy linear process, I think my PhD has actually looked a bit more like this. With the first 1.5 years sort of wandering around in the wilderness, not really knowing which way was up. The following 5 years felt like a bit of a black hole. Finally escaping that black hole, the last 1.5 years has felt like a bit more of a linear process with a few dips and alleys and troughs along the way. So that feels like the more realistic version of my PhD. So to skip to the content, let's first talk about the process of ocean acidification. It's very hard to talk about governing an issue without really understanding the science behind it. So this is a very simplified version of the ocean and the atmosphere. We have water in the ocean. We have carbonate ions in the ocean. We have calcium carbonate in the ocean. So calcium carbonate are the shells and skeletons. So coral reefs make their skeletons out of calcium carbonate. And these carbonate ions are the building blocks that they use to create their shells and skeletons. So we've got lots of CO2 in the atmosphere at the moment, and that's being absorbed into the ocean. And so as CO2 is absorbed, it actually bonds with water and forms a carbonic acid. And so how do we know something's an acid? Because it has lots of hydrogen ions that it releases. And so hydrogen ions don't like floating around by themselves. They find things to bond with. And so they tend to bond with these carbonate ions. And so whilst they're doing that, they're ultimately binding up the building blocks that are used by these calcifiers. And so by reducing these building blocks, it makes it more difficult for the calcifiers to build their shells and skeletons. But as this process continues and more of the carbonate ions get bound up, we're still seeing hydrogen ions being released. And so ultimately what this increased amount of hydrogen ions are doing, they're attacking already existing calcium carbonate structures. And so we're actually seeing the dissolution of existing calcium carbonate structures as well. So when we talk about calcifiers, which is one of the main impacts of ocean acidification, we've got sort of 2 processes happening. One, that it's becoming more difficult for them to create their shells and skeletons. And the second is that they're actually, once acidification progresses enough, they start dissolving as well. And so when we think about historically what's happened with the acidity of the ocean, so we can see since the Industrial Revolution, we've had a massive drop in acidity. And so what we're seeing today is really we haven't seen in the last 20 million years, perhaps even longer. And so we've got an unparalleled change of magnitude and a rate of change. And so that means it's very, very difficult for ecosystems to adapt naturally to this change that we're seeing in the oceans. And so what are the actual impacts when we as humans are concerned about the oceans? So as I mentioned, we've got those calcifiers. So one example of a calcifier is a pteropod. They're little swimming sea snails, often coined the potato chips of the sea because everything likes to eat them. But they're ultimately really, really important in polar and subpolar food webs. And once we start losing those pteropods, it's likely that there will be massive shifts in those food webs. And the pteropods we're already seeing, scientists are already finding in the Southern Ocean, pteropods with dissolving shells. And so likewise, we've got the benthic invertebrates. So again, another set of calcifiers, mollusks, oysters, coral reefs. These are critical when we think about ecosystem engineers, habitat creators. They're likely to have significant impacts as well. We've also got the whole sort of aquaculture industry as well, which is being impacted. Seagrasses and seaweeds are actually likely to do better under more acidic conditions because they like CO2. They also help to moderate local areas of pH. So seagrasses, however, are highly threatened. There are areas throughout the ocean where they're massively degraded. And so actually one of the ways that we could help moderate ocean acidification is by thinking about restoration of seaweeds and seagrasses. Jellies are also likely to do better. Again, species that we don't particularly like a whole lot in the oceans, but they're likely to do better in the future. And then we're actually seeing impacts now to higher order species as well. So many fish species, we've seen impacts to a lot of coral reef species, direct impacts, so sensory impacts, changes in brain neurology, things like that. Also, we're now seeing studies that are coming out showing salmon and other species that are really vital food sources as well. So ultimately, this all scales up to impacts to humans, to tourism, to fisheries, to coastal protection. And so we will be seeing a lot of significant impacts to human communities if ocean acidification continues unabated. So as I mentioned, coral reefs, they are one of the most impacted by ocean acidification. These grey dots show the distribution of coral reefs, and these different colours across the map show essentially the availability of that carbonate ion. And so coral reefs have traditionally only been found in areas where there are adequate to optimal levels of carbonate ions, those building blocks. And so as we move forward in time, we're seeing the areas shifting down to adequate, even to marginal. So that's where we are sort of at the moment. It's a little bit worse than that now. But as we move forward into the future, by the middle of this century, it's predicted that there'll basically be nowhere left in the oceans that are optimal areas for coral reefs to grow. And it has been projected that by the middle of this century, coral reefs will be in a state of dissolution. So coral reefs, obviously significant in terms of the way we think about the oceans, but they're also harbour up to 1/4 of marine species, vital in terms of tourism. So that's just one impact when we think about ocean acidification and the likely losses as we move forward. The other thing that is really important to take away from these maps is that ocean acidification is not constant across the ocean. There are different areas like the polar areas that are colder water, so they absorb more carbon dioxide. So acidification is happening faster there. But there are also local conditions which impact the rate of ocean acidification. And so those local conditions can also be moderated by our activities as well. So in terms of that, in terms of addressing ocean acidification, we've got that CO2 problem, which needs to be addressed, but then we've also got a lot of local activities which can be addressed to reduce ocean acidification. So that's the science done. And now I wanted to move over to talk, as I said, sort of the way that I approached this problem was actually thinking about how can we address an emergent issue in an already congested international landscape. So that was the fundamental research question that I wanted to tackle. But in order to sort of address that, the first thing I needed to do was understand, well, what's already happening in the international landscape and where are the gaps that exist? So I went through and had a look at all of the different MEAs that are out there, global MEAs, and had a look at what they had done to address ocean acidification. And so I found essentially that there are 6 MEAs that have mentioned ocean acidification in some way. So the earliest was under the London Convention, London Protocol, where they mentioned ocean acidification as a threat, and then decided that sequestering carbon into the marine environment was an effective way of addressing ocean acidification and climate change. They decided that putting it into the ocean was not okay, as it would exacerbate ocean acidification, but storing it beneath the ocean was something that should be allowed under international law. And so the London Convention and London Protocol is the only MEA to date that has really made sort of hard law around ocean acidification. The CBD, the Convention on Biological Diversity, has addressed ocean acidification and given a number of guiding options to state parties as to how they could address ocean acidification, largely in terms of strengthening ecosystem resilience. Then we've also had, under the Convention on Migratory Species, they've recognised ocean acidification as a possible threat, particularly to loggerhead sea turtles. The UNFCCC has acknowledged ocean acidification as a slow onset event. That is it. And the World Heritage Convention has listed ocean acidification as a threat to some of its sites. But that's it. When we think about addressing ocean acidification, that is the limit that has been done in terms of the international community acting through multilateral environmental agreements. So in order to understand where the gaps were, Ove and I wrote a paper where we structured a governing framework for ocean acidification. And what this governing framework did was essentially set out an idealized version of what an international governance of ocean acidification would look like. And so we set out 3 main objectives: that there should be mitigation, adaptation, and redress. And you probably can't actually read these, but essentially we set out 6 different areas for collective action and a series of different activities that could be undertaken in order to meet these collective areas for action. So when I mapped the different activities that are happening already in the international space onto this idealized version, we can see that the London Protocol, as we said, is talking about sequestration, so they're contributing to mitigation. The Convention on Biological Diversity is contributing to adaptation. And the UNFCCC, with its mention of ocean acidification as a slow onset event, which puts it under the loss and damage mechanism, has essentially put it under the redress element. But there are still a fair few gaps when we think about an idealized version of what governance would look like. And when we think about what the CBD and the UNFCCC are doing, they're not even legally binding. There are no actual mechanisms there at this stage. And even when we think about mitigation, the London Protocol, it's a tiny element in terms of talking about CO2 sequestration under the ocean. So again, when we look at the international scale, it's sort of hard to say that anything really is being done to address ocean acidification in a meaningful way. But we know that there are a whole lot of international MEAs that do address these issues already. So the UNFCCC obviously already addresses mitigation, adaptation and redress, and particularly focuses on the issues of CO2 reduction. The CBD, again, looks at all of these issues in terms of the adaptation issues. So thinking about ecosystem resilience, reducing pollution, those kinds of things. And then we also have UNCLOS, the UN Convention on the Law of the Sea, which has not yet really become a part of the conversation around governing ocean acidification. And yet ultimately it governs every human activity that takes place in the ocean. So it seems to be a place that we should be thinking about in terms of governing ocean acidification. So this is something that has started to become a part of the sort of governance literature around ocean acidification. And in the sort of mid to late 2000s, an epistemic community around ocean acidification started to arise. And a number of us wrote papers around how to incorporate ocean acidification into these existing MEAs. One of the things we really focused on, though, was this distinction between climate change and ocean acidification. And we made a real effort to frame ocean acidification as a separate issue. So climate change encompassed the thermal changes resulting from increased greenhouse gases, whereas ocean acidification was a CO2 problem, separate to climate change, but still connected in that ultimate CO2 driver. And this was a really important framing of ocean acidification, which came out of the epistemic community, because at the time we saw that conflating ocean acidification and climate change would actually result in significant policy consequences. This was largely in the US domestic context that we were working. And at the time, anything to do with climate change was so politicized that it was very difficult to get any policy movement on it. And so we realized that if we spoke about ocean acidification as a separate issue to climate change, we'd get more political traction for it. And so this became the fundamental way that ocean acidification was framed by the epistemic community. So this framing carried on to the academic literature as well. And there was at the time, sort of the late 2009 and onwards, an emergent legal literature which started to talk about the actual jurisdiction of existing MEAs and whether or not ocean acidification fit into those jurisdictions. And so the framing of ocean acidification as a concurrent problem to climate change within the legal literature ultimately set ocean acidification outside of the jurisdictions of most MEAs. So when I delved into this literature, it became apparent to me that the framing of ocean acidification as a concurrent problem to climate change had resulted in ocean acidification sitting outside of the jurisdiction of the UNFCCC. And the second issue of focusing almost exclusively on ocean acidification as a CO2 problem also meant that many of the other MEAs that had no jurisdiction over CO2 were largely left out of the conversation as well. So that led me to sort of thinking again, I'm going backwards, thinking again about some of my research questions. So how can the emergent problem of ocean acidification be addressed? Well, maybe it's actually a problem of reframing the issue It's not about the creation of new legal instruments, but about thinking about how we actually talk about the problem and how that problem can then be situated in existing mandates. And so that ultimately was my second and third questions, were issues around framing. So can reframing acidification play a role in filling the identified governance gaps? And then can reframing ocean acidification also enhance the synergistic interactions between these different regimes? So for the rest of my talk, because I can see I've only got 15 minutes left, I'm actually going to focus on just one of the case studies. So to answer these two questions, I did 3 case studies. I looked at the UNFCCC, I looked at UNCLOS, and I looked at the CBD. And these 3 different case studies basically examined the mandates of the regimes and whether or not a reframing of ocean acidification would allow ocean acidification to sit within those regimes, whereas previously interpretations of the regimes had placed ocean acidification outside. So I'm going to focus just on the UNFCCC. I figured as an audience at the Climate College, you'd probably be interested in the climate regime. So when we think about the objective of the UNFCCC, ultimately it talks about preventing dangerous anthropogenic interference with the climate system. So this is not talking about climate change, it's talking about the climate system. So how do we define the climate system? And the UNFCCC defines it as the totality of the atmosphere, hydrosphere, biosphere, and geosphere and their interactions. And so given the ocean acidification is an impact on the hydrosphere and biosphere, resulting from interactions between the atmosphere and hydrosphere, it's easy to see that ocean acidification fits within this definition of being an interference with the climate system. So no problems there. Everyone basically agrees that ocean acidification sits within this primary objective of the regime. The problem is that the regime essentially sets climate change as the avenue through which the objective should be met, addressing climate change. So again, in Article 3, we see parties should protect the climate system, but they should essentially do so by combating climate change and its adverse effects. And we see this repeated throughout the convention, that it's ultimately the addressing of climate change, which is the way that the convention should be, the objective of the convention should be met. So, well, can we define ocean acidification as climate change? And as I said before, we made a real effort to make sure that climate change, that ocean acidification was not defined as climate change. We've hence, or I have hence realised that that framing has probably come and bitten us on the arse, because climate change does not incorporate ocean acidification. So a lot of the legal literature suggests that the convention actually carries no obligation to address ocean acidification because ocean acidification sits outside of climate change. So what I wanted to do in this case study was actually say, well, can we rethink the framing? Can we actually say that climate change incorporates ocean acidification? And so climate change means a change of climate, which is attributed directly or indirectly to human activity that alters the composition of the global atmosphere. So we already know that human activity resulting from a change in the composition of the global atmosphere is what results in ocean acidification. But can we say it's a change of climate? And so the way climate has traditionally been defined within the convention is as the average weather. And this again is the sort of scientific pathway which led us to basically say ocean acidification and climate change, two separate problems. So under this definition, climate change means a change of average weather which is attributed directly or indirectly to human activity. And the adverse effects of climate change are the physical changes to the physical environment resulting from a change in the weather, the average weather. So this definition does not incorporate ocean acidification. Thing is, the IPCC tells us that climate in a narrow sense is usually defined as the average weather, but climate in a wider sense is the state of the climate system. So the UNFCCC itself doesn't anywhere define climate in the treaty text itself, and in none of the subsequent agreements or activities has there ever been a definition of climate made. So traditionally, we've all sort of used this definition, largely because that's where the scientific community has sat. Predominantly the modelling folks, thanks to people like Malta and Zeb. But the IPCC tells us that actually we can use this broader definition of climate being the state of the climate system. And as we know already, when we're thinking about ocean acidification, climate system incorporates ocean acidification. So if we use this definition, the state of the climate system, climate change means a change of the state of the climate system. And adverse effects of climate change mean the changes in the physical environment resulting from a change in the state of the climate system. So ultimately, if we use this definition, which is scientifically defensible, ocean acidification sits well and truly within the UNFCCC. The problem is you can't just decide to interpret a treaty however you want to, right? So there are actual rules around this. So there is a convention that sets out the laws as to how we interpret treaties. And so Article 31 tells us that a treaty shall be interpreted in good faith in accordance with the ordinary meaning to be given to the terms of the treaty in their context and in the light of its object and purpose. Article 32 tells us that when there's a little bit still, if we're still a little bit sure as to how we interpret these rules, that we can actually go back to the negotiating history as well and use them as a supplementary means for interpretation. So let's go back to the UNFCCC again and think about, okay, in their context and in light of the object and purpose. So in their context, we have time and time again, so the preamble, the objective, the principles, time and time again, the convention states that the primary objective is to protect the climate system. So ultimately, it fits very easily within the object and purpose and within its context. Secondly, when I looked back at the negotiating history and read through all of the documents associated with definitions and coming up with the object and purpose of the treaty, there was actually a really interesting shift. The beginning of the negotiating texts reflected climate as being defined as the average weather. Over the period of the negotiations, all of those definitions using climate as the average weather had been dropped out. And actually now that all of the parties referred to, towards the end, all of the parties referred to the climate system. So all of those places where the climate had been referred to had been replaced with the climate system by the end. And so that reflected the transition that was happening at the time in terms of the scientific community, in terms of understanding the really interconnectedness and the interconnected nature of the climate system as meaning more than just the average weather, but actually incorporating the hydrosphere in as well. And really understanding how significant the oceans were in terms of governing the overall climate system. So this is a very shortened version, but ultimately my understanding of the object and purpose of the treaty very much aligns with using climate system rather than the average weather to define climate. And so I believe that actually this is a far more relevant definition and interpretation of the treaty than the way we have previously interpreted it. And so that ultimately means that ocean acidification no longer should be seen as a separate issue to be addressed incidentally to climate change, but ultimately becomes one of the main elements that need to be addressed in order to say we've successfully achieved the objectives of the treaty. So it really fundamentally shifts the way we think about ocean acidification in the context of the UNFCCC. So that was a quick summary. So very, very, very quickly, the other two case studies that I looked at were UNCLOS, the law of the sea, and ultimately found many, many provisions within this treaty, and I'm not going to go through them, but many provisions within this treaty which were relevant for addressing ocean acidification, and suggested that there is an obligation for all parties to respond to ocean acidification. And so ultimately, I think that this treaty, the law of the sea, should actually act as sort of a framework convention for ocean acidification and act as the guiding principles for the international community as to how we should address ocean acidification. The third case study that I did was on the Convention of Biological Diversity. And next year, there's going to be a renegotiation of the biodiversity agenda for a post-2020 era. And the biodiversity agenda essentially sets the agenda for the CBD, but also the broader UN community as to how biodiversity should be addressed. And so ultimately, in this chapter, I suggest how ocean acidification can be streamlined or integrated across that biodiversity agenda, and how addressing ocean acidification more broadly across the agenda will actually enable a far more meaningful response, rather than just situating it in a few of the climate-related elements that are currently addressing it under the CBD. So the very conclusion of it all is that ultimately these three regimes, the climate regime, the biodiversity regime, and the law of the sea, are three fundamental elements which need to be rethought in terms of addressing ocean acidification. And if we do reframe the issue as, in terms of the UNFCCC, as an effect of climate change, and in terms of UNCLOS and the CBD as an ocean issue, broader than just a climate-related issue, we can actually see there are a whole lot of provisions which result in obligations on state parties to address ocean acidification. And also the reframing I found actually results in decreasing some of the conflicts between these regimes as well. One example in particular is the UNFCCC at the moment talks about enhancing carbon sinks. And so that has actually been understood as even encouraging active sequestration into the ocean, which could result in exacerbation of ocean acidification. Under the CBD and the London Convention, as I mentioned, they have basically said that there shouldn't be active sequestration into the ocean because it's likely to result in an exacerbation of ocean acidification. So at the moment, the way the UNFCCC has been interpreted allows for this element which is directly in conflict with the regulations under other regimes. So a reinterpretation of the UNFCCC to incorporate ocean acidification actually enhances a synergy between the regimes and those regulations, because no longer would active sequestration that allows an exacerbation of ocean acidification be allowed. It would actually be something that would have to be avoided, which is the regulation under the other regimes. So that's basically the overview. Why do I keep pushing the back button? So that's sort of my PhD in a nutshell. If you are interested in looking at any of my publications, there's the list of those which have come out during my candidature. And I just also, as an aside, wanted to point out this artist, which some of you may or may not have seen of before. She takes scientific data and turns it into art. And so this is her translation of declining pH in the ocean. And so I just thought it was a wonderful image to end my talk on, that we spend a lot of time talking using words, but there are people who can, I guess a picture conveys, what is it? A picture is 1,000 words. And so I thought that that was a rather fitting way to end. So thank you. I guess people might want to ask some questions.
Yes, a terrific, tough, tight, and rigorous presentation of a terrific, tough, tight, and rigorous thesis. We've got about a quarter of an hour for questions, so we'll just open the floor.
I think there's a mic coming.
And Alan, I'm just wondering what the how realistic that is to distinguish adaptation from mitigation when we're talking about change of ocean pH. I mean, we either accept it as an inevitable, which is, I suppose, one aspect of mitigation, of adaptation, or we deal with it. But it's a little bit different to average global temperature, you know, where I think adaptation has got many elements, but I can't quite see what they would be. Although I know you had some, which was too small to read, but could you explain that a little?
Sure. So I guess firstly, adaptation and mitigation need to go hand in hand. You can't do one without the other, I don't think. We could have mitigated without adaptation if we'd done it early enough. But at this stage, we're already seeing impacts from ocean acidification. So there's one example, which I think is a wonderful example of adaptation, which is along the US coast. There are shellfish hatcheries along the US coast, so aquaculture farms where they grow oysters. And so in the mid-2000s, they realised, so there's upwelling along that coast. They realised that every time there was an upwelling event, they were seeing massive die-offs of their spat, so the baby oysters. And it was attributed to increased acidification because the larger CO2 signal was now being brought up by the upwelled waters. And so it was ultimately attributed to ocean acidification. So what these farms then did was they set up monitoring systems, which resulted in essentially early warning systems, which allowed them to shut off all their valves. So whenever there was the indication that an upwelling event was going to occur, they shut off all the valves, turned all their systems internal, closed circuits, and so none of that upwelled water was able to come into their systems. And so it's a way that they're now adapting to the issue. And so, but it was ultimately understanding that it was ocean acidification that was causing those die-offs that allowed that to happen.
Good example. Thanks.
Yeah, sure.
I've got the microphone, so I'll go next. And what might help with that question, and you sort of skipped over a bit, is do you want to go back to the beginning and talk about the 6 sort of categories of actions that you think sort of fit into the OA governance space, and maybe your views on, I guess, which ones need to be prioritised, etc.
Yep. Get rid of all those lines. Okay, so the 6 areas for collective action that ultimately need to be addressed in order to respond to ocean acidification. So the first 2 fall under mitigation, and they are ultimately, can you actually read it or not? No. Okay, so the first one says reduce CO2 emissions and remove CO2. So ultimately they're sort of the 2 ways that we're thinking about mitigating ocean acidification. So ultimately we can't address ocean acidification without reducing CO2 emissions. And then there's obviously fairly substantial conversations within the climate community at the moment about removing CO2. So one of the issues with removing CO2 though, are that many of the suggestions as to ways that we should do that incorporate utilizing the ocean. And so many of them actually have the possibility of actually exacerbating ocean acidification. And
For the next generation.
so for that reason, I think it's not just gung-ho, let's remove CO2, but actually we need to regulate it in a way that recognises ocean acidification as well. So then the second branch of addressing ocean acidification is adaptation. And so within this, we've got strengthening resilience and adaptive capacity of ecosystems and human communities that rely on ocean systems, and reducing local pH as well. And so there are many activities, many pollutants that actually contribute to ocean acidification. So shipping emissions, SOx and NOx, so sulfur and nitrogen, contribute directly to an increase in ocean acidity. We've also got other pollutants, a lot of runoff, so runoff that ends up in the ocean from rivers, farms, agriculture, things like that. And so reducing those local pollutants can actually mitigate a fair amount of local acidification. It doesn't impact the global signal, but can change the local conditions enough that it can allow additional time before some of those ecosystem thresholds are passed. And then the third element is redress. So in this respect, we've got sort of restoration of ecosystems, but then also harm management in terms of human communities. So in the climate conversations, that's really loss and damage. So things like insurance, which is a really difficult conversation when we're thinking about slow onset events, and something that hasn't really been addressed very well within the literature, and something that we need to think a lot more about, and not just in terms of ocean acidification, but slow onset events in general and how they can actually be dealt with. Because at the moment, when we think about loss and damage, we tend to largely think about sudden impacts. So storm events, things like that. And so we're actually seeing sort of a lot of insurance and things are being built around those impacts, but we're not really at the stage where we've got good solutions for these slow onset events yet.
Will I ask another question?
Ellie, this one comes from online, from Rowan Burns. The question is, in regards to the pure science of ocean acidification, how is negative ionisation in the climate system significant? And given the change in impacts of CO2, how can this be improved by impacts of positive ionisation? I hope you know what that means, because I am not an expert in that field either.
Malta, can you answer that? I actually can't answer that question, sorry.
Thanks, Ellie. I've got a, I think, pretty simple or dumb question. Maybe you've sort of touched on it too. The fact that there is an equilibrium between the ocean and the atmosphere, I'd be interested to know, why doesn't that like there is an exchange between the carbon in the atmosphere and the ocean. Why doesn't that automatically mean that it is part of the climate system? That in my mind is a direct link. So anyway, perhaps you can elaborate on that.
It's a good question, and I think it depends who you speak to as to how they define. Well, so climate system, yes. Oceans has always been considered part of the climate system. It's how you define climate, though, which can be defined as the average weather or the state of the climate system. So the climate system, yes, has always been understood to incorporate oceans as part of it. Does that? I'm not sure I quite get.
In the ocean,
yeah.
I would have thought that was a straightforward link, but yeah.
Well, I think, yes, it should be a straightforward link. And I think I think logically it seems, where we're standing now, it seems like it should be something that is easily understood. I think though, in terms of the way the sort of science has evolved and thinking around the regime has evolved, that climate and climate change has traditionally been thought of as just the thermal impacts. So the ocean would have been considered in terms of sort of CO2 flux, but in terms of the actual chemical changes that were taking place in the ocean, were not considered to be part of the climate system that was being dealt with by the regime, if that makes sense.
How much has this debate impacted on negotiations? Because it seems to me, for example, there's been massive resistance to the loss and damage agenda around insurance and reparations. You're broadening the agenda. Has this debate fed into negotiations, and if so, positively or negatively?
So that's a really interesting question. Generally, the answer is no, ocean acidification has not factored into negotiations within the UNFCCC. But the one space that it has is within the loss and damage space. The one mention of ocean acidification within any outcome documents of the Convention of the Parties has been when ocean acidification has been mentioned in a footnote which described a series of different slow onset events in terms of the loss and damage conversation. So really the only space that ocean acidification at the moment is considered within the UNFCCC is within the loss and damage space. But ultimately, I think we need to have a broader understanding of where ocean acidification needs to be thought of, particularly in the mitigation space as well, which as yet, ocean acidification has not featured in any of those negotiations. I think Svenja had a question. I think there's one just behind you. Nope.
Yeah, can you comment on whether aspirational targets could play a role, because there is the Sustainable Development Goals that do include acidification as a real target. Mm-hmm. Have you got any view on whether that could play a real big role? Mm-hmm.
So ultimately, the driving force behind this governance framework was to minimise and address ocean acidification, which is the wording of the SDG 14.3, which talks about ocean acidification. So ultimately, this sort of started from, there is a sustainable development goal talking about ocean acidification. There is absolutely no guidance as to how that goal should be met. And so this governing framework ultimately suggested a way that the international community could engage with that SDG. In terms of my actual case studies, the CBD, the Convention on Biological Diversity, is ultimately a look at aspirational targets, because the way the CBD works is essentially sets, at the moment, what it does with its biodiversity agenda each time, it sets a series of targets that are largely aspirational and then hopes that its state parties meet those targets. And so what's being renegotiated for next year is likely to be another series of aspirational targets. And so that whole case study looked at how we can actually incorporate ocean acidification into those targets.
Thank you. Ellie, this is another one from online from Ove, who says, great seminar, very impressive. And then asks, what is the role of science going forward? And how would you improve the dialogue in terms of the science and policy communities?
It's a very good question. So I think one of the issues, in a way, is that the various communities largely sort of talk to themselves. And I think that was one of the problems in a way that resulted in the current framing of ocean acidification. That we, as the epistemic community in the US, which were largely a scientific community, didn't speak to the sort of legal community at all in terms of what could be the repercussions of the framing. And so whilst we addressed a very particular issue within the US political system, we didn't have that expertise within the community to actually think about, well, what are the ramifications of this framing? And so I think actually one of the most important things moving forward is figuring out ways that we can have these multidisciplinary conversations about the future and about the way we move forward. I don't think these problems can be solved within just one of these communities. We need to be making sure that we're bringing all of our expertise together. And I think that's sort of what I've tried to do here, is try to bridge some of those gaps. But I think there's always going to be a role for science. I don't think we can ever say, well, we've got enough science and we can just move forward. The more science we have, the greater understanding of the impacts is always going to be a good thing. It's always going to be helpful as we're moving forward.
I'm Ian Blair, Agriculture. Following on just what you've mentioned just now, what has been done in the legal side of accessory after the fact? So acidification is an accessory to global warming, and then you get global warming, which releases more carbon dioxide, and that maybe reduces acidification, but it's a tipping point on global warming and carbon dioxide in the atmosphere. If you get the legal people involved, if they can see there's a legal case, boy, will they jump in. So have you investigated that?
So I have not investigated litigation around ocean acidification. Yet there is, in the Australian context, there's no litigation around ocean acidification. In the international context, there is none. In the US, there are a couple of cases which are moving forward, which are largely climate cases, but have mentioned ocean acidification as well as problems. But that's not something that I've personally researched at this stage. But yes, there are a few cases within the US context where ocean acidification is part of the case moving forward.
Time for one last question. That was almost a moment for one of those lawyer and codfish jokes, but I won't go there. Are there any more questions? One last question.
Hi, Ellie. That was really interesting. At an Australian level, there's just one sort of example that was popping up in my mind as you were talking. I don't know if it's widely known, but Australia doesn't have regulation for sulfur content in fuel oil in our shipping emissions. So consequently, international ships swap to the worst grade bunker fuel as soon as they get to the Australian waters. And shipping emission, really high concentration of SOx and NOx, more so in Australia than anywhere else in the world as a result of that. So you're nodding, so I guess
yes.
You know. So has your research, I mean, is there any sort of recourse for action in terms of the tourism industry and the Great Barrier Reef? I know you looked at a broader international perspective, but look, it was just crossing my mind as you're talking, and I'm interested if you identified any.
Yeah, so I haven't, again, I haven't looked at in the Australian context at all. The reason why I was nodding is because I have looked into MARPOL, which regulates shipping emissions. And in general, MARPOL has set regulations that sulfur content needs to be increasingly declining in the future. So we will be seeing a lot of those bunker fuels, the heavy, heavy bunker fuels, being ruled out in the future from use, even in Australian waters. But what MARPOL does do is allow for specific countries to designate areas where they want to see even lower sulfur content used. And so that's an avenue I think that many countries can move forward, and it would be wonderful to see Australia move forward with that and actually designate areas of the coastline where it would like to see those lower sulfur fuels used. But again, it needs to be a push sort of domestically to put that on the domestic agenda in order for that to move forward. But yeah, I mean, yeah, and there are studies that actually show sort of sulfur from shipping can contribute an equal amount to the global signal of ocean acidification. So in some areas, sulfur and other emissions from shipping can be significant exacerbators of ocean acidification. So really important that we actually get it incorporated into thinking around shipping emissions. And at the moment, ocean acidification is only thought of in terms of the CO2 emissions from ships and is not considered at all in the sulfur or NOx emissions from ships. So another area where it really needs to be thought about. Yeah.
Sadly, we're out of time. I just wanted to say hello to Ove, and it's very nice to have Ove Harrould-Kolieb online as well, so all the supervisors are in the room. Thank you all for coming. I'm sure you want to join me with me in thanking Ellycia for a fabulous seminar.
Thank you.
Done. Can I just let you know that next week we have another fabulous PhD completion seminar from Nick on the Europeanization of the Renewable Energy Directive in France and the UK. Same time, same place.